We really? Hey everybody, thank you for coming out. My name is Brian Warner, I'm in the Cloud Services Group. I wanted to welcome Jared Chong. He's here from Yubico. I know Yubico is the company that makes the Yubic keys, those cool little two-factor one-time password dongles. They're really cheap and easy to use. But I met Jared at the Internet Identity Workshop a couple months ago where they were doing a presentation on a universal second factor thing with an industry alliance called FIDO that reminded me a lot of Persona. I thought that there could be a lot of synergy there. So please welcome. Jared's going to talk about the FIDO Universal Second Factor project.
Thanks, everyone. I'm actually really happy to be here because it's not very often that we get talk about a new open standard that potentially can, I believe personally, will affect us at a very personal level. And we'll see, the questions that you have, but hopefully that will get you thinking a little bit on, beyond the everyday use today that we've so tired of in terms of authentication. So what we're trying to solve here, and I think that everybody agrees that online authentication is kind of a means to get to something else, to authorize you to do something and get somewhere. And if it's difficult, you can impact you on a daily basis and impact business on a daily basis as well. So what we're really trying to do here is stop this notion that we got to constantly ask users for passwords, right? And that is a challenge in the industry. And all the technology companies out there are still grappling with this issue. This has been, ever since we've created the internet, so to speak, or even first computers, so to speak. Kind of step back, I just wanted to ask a question, right? So you guys are IT professionals, security folks. Would you read documentation or do coding, or would you B, teach your mom how to remember a complex password? Who's for A? Who's for B? No one. Wow. So this is a problem, right? And why is it a problem? Because we made it so difficult to create a system to let the everyday user get online. And for those who are, the mama's boy, this is a pretty good cartoon here that I found. But in essence, we are grappling with this every day as individuals that actually know how to do these things. And then we have the mass market that just have no clue what this is all about. And so I point you to the next slide. Are you guys familiar with this cartoon strip XKCD? You guys are probably very familiar with this. And this is this is a kind of a known issue here. And we've really spent a lot of time trying to make passwords so hard to remember for humans. And it's actually fairly trivial for a computer to just switch things around. I'll just tell an interesting story now that we had a topic of mom on board. My mom called me a couple days ago, and she usually calls me over Skype, and she says like, I need to talk to you. I said, well, you always call me over Skype. Why do you call my phone? You're wasting my minutes. So I said, what's up? It's like, well, I forgot my password, my Skype password. I said, well, that's easy. Just go reset it, and it'll send to your email account. Oh yeah, I forgot my email account password as well. I said, why don't you just use Dad's account? And she's like, well, he forgot his password as well. So this is a systemic problem. And she called me back 15 minutes later. Sorry?
A systemic problem in your family.
It is. And I'm sure you can all relate to this. And 15 minutes later, she calls me back on Skype. I'm like, wow, great, you remember your password. I was like, that's awesome, you remember your password. Oh, I didn't remember my password. I created a new account, and I made the password your birthday. So, this is happening today with us every day, with our families and our friends and so on and so forth. So we really need to get away from this whole notion that just because it's easy for us as web developers or the community to develop apps, and then we make it a trivial thing to incorporate username and passwords, and then you put this on the burden of the end users, right? So that's got to change. So the big thing is that it's not just about complexity of passwords. It's not just about asking people to remember, 30, 40 different passwords for 30, 40 different services. But there are really real security issues here, right? And one of the things that we know users are doing today is reusing the passwords. So like, it's good that what came back from the Cloud Identity Summit, good that we want to reduce the number of IDPs. But if every IDP is still asking for a username and password, we're not really getting to the real problem here. And let me ask you another question. How many of you have received an email over the last year asking you to change your passwords? Okay, for those that didn't, maybe you didn't check your junk mail, or maybe you're not that social. But this becomes a problem of now I have to reset for one site. Did I create the same password for another site? And what are those sites? I don't remember. The next scenario problem is of course being phished, right? It's so easy to phish a password, right? It's easy to convince an end user that they need to check a message from the bank and go put in your username and password so you can check a message. Very common scam phishing attempt in the marketplace. And then keylogging. And there's no way that you can come up with a complex enough password that you will get around this last challenge of passwords. So we have a problem here. And it's not to say that we haven't tried to solve this problem. We have many large internet companies, many very secure companies trying to solve this. And the problem is that either been siloed within their specific industries, or it has been, at most, a niche market. And the biggest internet giants have been trying this as well, and it all leads down to it's not mass market yet, right? So we've got some of these items here with SMS, getting SMS code on your phone is being hacked already, we know this. And usability of reading, digits from a token is, again, friction. And so it all boils down to nobody wants to use it. Nobody wants to use strong authentication because it's too difficult, and the service providers are just not in the business to make it difficult for their customers, right? So we know this. So there's got to be a better way to do this. So I'm putting on my FIDO hat today. I'm with Yubico, and I wanted to talk to you about what we're doing here at the Alliance and give you ideas from potentially how do we move forward with working together. I think the community needs something better. There are two standards that we're proposing.
Can you explain what the FIDO Alliance is?
Sure. The FIDO Alliance is the fast identity online. So when I talk about the friction, that becomes a huge showstopper for the consumer in general. So if you make it difficult to assert your identity, then you fail. So that's what the FIDO Alliance is, trying to make assertions of identity very, very quick. So there are two protocols that we are focusing on. The U2F standard, which is really the big leap to really no passwords. And then there's the U2F standard, which is taking a first very important big step to get away from passwords, which means that you could reduce the complexity and the number of passwords that you actually remember. And I explain specifically today the U2F protocol, which I think that you as the browser community can really help to drive this standard. And you kind of see why in a couple of slides. So the experience for the U2F is really you have a login with a username and a simple PIN or a very simple password, and you have a second factor to do the identity assertion for you. And then you're done, and you get in. So what is the kind of key motivation that we are proposing with this protocol? It's essentially to bring your own authenticator, so to speak, and use the authenticator for all services as long as they follow the protocol. So we're flipping this model around in terms of, instead of services provisioning you keys and things like that, you decide which service you want to associate this key with. And the experience must be extremely simple, which means it's really putting in the authenticator and touching a button or doing an action and not typing a sequence of numbers or doing something complicated, which is what a lot of users are doing now. And it's got to be, all the premise that we talked about, you can't be phished, and it's got to be preventing from key logging and things like that. It's all going to be trying to solve that at the same time. So kind of going down a little bit, what's the protocol about? Really, the protocol is very similar to the concept that you guys had at Persona. I know Brian gave me a quick brief on that, which is really using public key cryptography, because that's the only way that you're going to get away from password vaults. Password vaults are a symmetric key system, and we know the limitations of that system. In order to reuse the same password for all the different sites, you're actually sharing your secrets to every single site, right? So really, we're using public key cryptography, which is by far, this is what the industry recognizes as the way to go forward for any true secure systems or protocol. And what it does is that the device actually mints the key pair. So because we talk about open standards a lot, we don't want to introduce any third party here where they are controlling your certs and things like that. So that's why this is important. The device mints the key pair. And all the services or relying parties have to do is to, do the identity challenge, and the token can do the identity verification, right? So it's assertion so that it can be verified. So we're really looking at a scenario and an ecosystem where if everybody's following the protocol, the services don't have to know what keys you have, which does actually play very well in the privacy of today's world, because you can create a username and password without really knowing who you are, and you can extend it. You can extend this same protocol to many different sites, and the same user can use it for all the different sites. So you as the user can decide what you want to do with it. First of all, you can trust the manufacturer of obviously the device, and the service provider can also trust the device, which means that they can blacklist certain authenticators if they don't trust it, they're not made in a secure way or whatever criteria that they have. Maybe a banking site needs a more secure token, but maybe a blogging site, well, a soft token may work, right? That's up to the individual relying parties to decide what makes sense. And it's got to be pragmatic, and it's got to be usable, right? So that still needs to hold true. You can't be introducing a whole new system and then asking, your mom to remember another complex password, or you ask somebody else to do very crazy actions to try to authenticate the user. So these are design considerations, and we'll peel it back a little bit. But think of it this way: we're trying to create an ecosystem where these authenticators are smart cards, but the model is kind of flipped around, turned upside down, so to speak. As opposed to having root CAs generate certs, these devices are the ones that generates the certs, and they are the ones that do the assertions, which is really a very elegant protocol if you take a closer look at it. So at a high level, let's talk about a little bit about the flow here. And there are really three major components here that one of them really applies to your community, right? So we have the relying party, right? The companies that set up the services, and the relying party could be an IDP as well. And you have the end user, which is in possession of the authenticator. And then you have this middle layer, which is the FIDO client. And the FIDO client needs to be very intelligent, because it needs to know how to handle the requests coming from the servers and talk to the authenticators. In the case that we're talking about today, we are looking at the browser as the FIDO client. Why? Why is that important? Because when you introduce the FIDO client in the browser, the user doesn't have to do anything. If it's natively built into the browser, then I'm not asking my mom to download the software, and then she doesn't know how to install it, and then it crashes, and then it's a big problem. And I get a lot of calls in the middle of the night, which I do. So we're getting away from that. We're just making it easy for the end user if the browser is the FIDO client. And obviously, from an authenticator perspective, it's got to be driverless, right? I talked about it before, so that there's no additional driver installation, right? We hate driver installation. And then the driver fails, and then you go to manufacturing and it says, what's the latest thing that works on, Windows 8.1, and it doesn't work. It worked on XP, now it doesn't work on 8.1. So these are the issues we want to get away from. So this system basically states that the web app is called by the browser because the user wants to get to the service. It communicates with the browser. The browser communicates to the web app through the JavaScript API, and we'll talk a little bit about that in a bit. And the browser also knows how to talk to the token, and in this case, we are using the the HID trans protocol over over USB. So we have a USB protocol. Yes.
Which is bidirectional. This conversation. Oh, right. Sorry.
So is the HID, does that enable bidirectional communication so that you can query the device and it can give you a response?
Yes. So we actually at the work group, the technical work group for the U2F technical working group, we have a proposal on how it should work. There are several commands that you can put to the authenticator, and they need to respond. So yes, okay. We can get into that later on, and that's obviously one of the areas that we at Yubico have been focused on to make sure that at that low level it still works. But essentially, the browser needs to have a HID stack so that it can talk to the authenticator directly without going through the OS. And there are a lot of advantages for that. There are also some challenges. So this is a very active discussion in the technical work group right now. But we have a proposal on the table. So far, there hasn't been any, I would say, major objections. So we can talk about it later. But in essence, now that the browser can talk to the authenticator, then one of the key pieces as well that the authenticator devices need to implement is what we call test of user presence. So it's not just good enough to leave your token in there and just let the assertion happen something magically, right? If you are actually going to authenticate to the service, the service will provide a challenge, and the authenticator needs to do something. And in this case, the authenticator, from our perspective, is flashing, is blinking, and you have to touch it so that there's an intent, and to show to the browser that you are present, as opposed to, for example, leaving a smart card in and it's authenticate a session. So there's a challenge and respond protocol going on here, which is very critical to this whole ecosystem. So any questions on this three major components? Because it really is the foundation of this U2F protocol. Good. So I'll get even lower, which is kind of getting to the meat of it, and you probably have some questions here. But this is a flow in terms of the raw messages going from the relying party all the way to the authenticator and back again. And this really sums up a lot of why we think this protocol makes a lot of sense. So when you're logging into a site, we're making an assumption that you have authenticated the user, and now you want to register a authenticator to the site, right? So the user is authenticated, and he wants to add this authenticator as the strong second form of authentication. So when we do this registration step, the first thing that the server does is to send a challenge and the app ID. Why app ID? And it's a good question. So we are looking now, browser being equals FIDO client, but there could be a situation whereby FIDO client could be something else. It could be maybe an application on an Android phone or an iOS. So there needs to be a way for the protocol to go beyond the browser wall. Obviously, the browser wall is, it's easy because you know the web origin and you can associate it easier. But there may be even situations where the relying party could have a couple web origins associated with a specific app. That's plausible. So it first needs to check that are you one of what we call a facet of an application? If you are, let's proceed. So when we proceed, this is where you can see that the FIDO client plays a very critical role in deciding what to do next. So it has to create another challenge based on the first challenge you got from the service. And you're going to add a couple of things here, namely the origin, which is very critical. And I'll talk about why origins are very important. And then you may add channel ID. This is a work that the folks at Google have been working on. But channel ID is an option. In the protocol, it says specifically it's an option. But at minimum, you are adding challenge and origin, and you can add session IDs and other things involved in it. So there's a whole breadth of parameters. But at minimum, you need the challenge, you need the origin. And then you send a hash of the app as well. And you basically give it the authenticator. And the authenticator says, okay, I've got all this information, and that's where it mints this key pair for the service. Basically, it creates a key handle, public-private key, and now it knows, and authenticators are different implementations. I won't talk about Yubico's implementation, but essentially you need to have a way to get back that this key handle is for the service, right? There are many different ways to do that. But once you've done that, you're essentially sending back to the FIDO client, which is the browser in this case, the public key, the key handle, and you are also sending the signature. The signature here is important because the signature is really to attest that it's being signed by in our case, the YubiKey, as opposed to some other authenticator that is maybe rogued. So we have an attestation cert as well. So it needs to be signed by this device. So during the registration process, the FIDO client will take all this information back and send it back to the server. So now what we have is that the relying party can accurately verify that it's coming from, first of all, a specific authenticator that you want to bind it to, and also can verify that it has this key pair, or in this case the public key with the key handle that it can associate with your account. And however you set that up, it's really on the relying party itself. The protocol does not specify how you do the storing and what else you want to store. That's up to you. So by the time you're done with this registration, the service can now clearly identify that with this user account, you have a authenticator with a specific public key and a key handle associated to it. And each service will have this process going. And no service will know what the other key handle and public key is for that service, which does abide by the privacy constraints that we've set for ourselves in the alliance. So what happens next? Well, the next thing that happens is that you have to assert your identity. And so when we do authentication itself, what do? You send back the key handle with your app ID and another challenge, or whatever challenge that you want. And so you do the same checking. Are you even, first of all, a valid origin that is supposed to even do this operation? So the browser can check this. And again, we talked about the same thing. The origin needs to be in the challenge and so on and so forth. But this time, when this whole package gets back to the authenticator, what's going to happen now is that the authenticator can unwrap or derive the private key, and then it's going to use the private key that it minted before to sign the challenge. So in this case, we abide by the public key cryptography model, which is, it's secret. The private keys are secret on the authenticator, and they can be extracted. And then the other components here, where you can add counter values to identify if there's maybe a clone authenticator somewhere out there that you can flag. But in essence, you are trying to provide a system, the way to clearly identify and verify that this was the authenticator that actually created this key. And then from then on, you basically can have a very strong signal for the identity assertion, right? So that's really the core of what we're trying to solve here. I'll go another step deeper, which is just looking at some of the reference code that a lot of the people in the work groups have created. So you can see here we're looking at just a register request. The register request, we talked about, one of the things we talked about is the challenge. The challenge will be wrapped into what we call client ID, client data. And the client data involves the challenge and obviously the app ID. And so we talked about what an app ID is. In this case, it's actually just a pointer to a URL, and it's just a file, a JSON format file that you can list all the other facets of the application that you can actually allow to register. And then when you send back the client data, so you have this information about the challenge, you have the origin. Origin is very important, right? So the origin, go ahead, you got a question.
Can you give an example of a facet in this context?
A facet would be, so one facet could be just the web origin call. Let's say you have just the website. Another facet could be an Android APK that's signed. Another facet could be the iOS bundle ID, right? So there are different facets you can. And even within a application, maybe several different web origins are related to the same application. So maybe you're registering to a login page account. Maybe the store account would be probably maybe also the administrative web origin if it's the same, for example, in this case, acme.com. So accounts acme.com, maybe another facet may be the store reset acme.com. So you could have multiple facets for one application.
And so the idea is that all of the you use the same key pair for responses to all of those different facets?
Yes, correct.
And so is it that any website that knows the key handle can cause a signed response to be generated, but the origin is embedded inside that response so that the real recipient won't be tricked by a different relier getting
yes.
accounts?
So there's actually a lot of active work in the discussion of App ID and Facet ID currently in the work group. It's really the big players thinking about it are the eBay, PayPal folks, and the Google folks. So the motivation is pretty simple. I've explained to you one use case, but the motivation is also so that you can't, for example, have someone listing out different web origins that don't have, let's say, DNS suffix type of frame. You can't really, you can't divert too much. There are some privacy issues that we need to consider. Those are currently in proposal. But we need to give relying parties options to use the same key pair or the key handle and the public key for other services within the community. But we need to have some bounds. We can't just say, just because, for example, we know that YouTube was bought by Google, we don't want to kind of, we need to be clear that you can't have just different domains having this whole list, and then you can, then you don't restrict your privacy policy that we try to achieve. So, but we need to give flexibility as well, because we understand that an application could have more than, can take more than one form besides the web browser.
It's kind of the tension between the convenience of a single sign-on system across multiple domains and the privacy leak when different domains can realize the same person is logging into each of them.
Absolutely, absolutely. So there's a very active discussion, and if you want to be involved, I'll be happy to put you in contact with some pretty heated conversations. But I think we're getting to a point where everybody has made their statements, and there's a good compromise, which I'm very happy about. And of course, when you do the registration, this is the raw message data that gets back during the registration process. So as I talked about, the signature, the attestation cert, the key handle, and then the public key as well as sent back. And when we do the sign request, very similar process. Difference is that you're sending the key handle as well, and you are basically providing a very similar response. The difference this time, as I've mentioned, is that now you sign with your private key that you can only create on that device, and you send it back to the server. So a lot of the discussions around the workgroup now is really about focusing around kind of other areas, which means that this protocol is fairly set in stone right now. So it's in review draft right now, very close to implementation draft. So there are I would say, very little open questions that hasn't been addressed, and the things that are around what is discussed is not what I put out, which means that this protocol is fairly set from this perspective. Now I want to pause for a while and just want to make sure I've answered any questions before I show just kind of a demo of how this actually works. Any questions? Anything from the forum? Okay. So I have with me a YubiKey. I don't know whether you guys can see this. It's a YubiKey. So this is one of the form factors that you can create as an authenticator. And there is a touch sensor here so that it flashes when it asks you for the test of user presence. And it's connecting over the USB port here. So I'll bring up a site here that, so we have a test server, and there are actually a number of companies doing reference code and test servers today. We've done our implementation here so that you can see what it means. And for the purposes of showing what we do, we have some technical details at the top, technical data once we are registered and once we're authenticated. So just let me log in here. So I'm registering this device to this account. Today, there are already systems in place to do this. Everybody that creates any type of account, whether it's a mail account, web store account, banking account, there's already an existing system in place. So what we're saying is that we're introducing this additional layer here to really help strengthen that baseline credential verification and authentication that companies are using today. So Nix is registering, and right now the browser is communicating with the site, and it's going to ask me to enroll. So the enrollment process right now, you can't really see it, but my YubiKey is flashing, and it's telling me that I'm going to, I've said I want to enroll, and now the server says, okay, now go ahead and enroll.
Is this a special new YubiKey that is different from the ones in all of our pockets?
Very, very good question. Yes, it is.
Okay.
It's very different. In this case, you can tell that this YubiKey doesn't really care about the number of slots. I know you had a question on that because it can mint as many as it wants. So, okay, let's take a look at the registration data here. So we have the login data. I created my login, username, password. It can be very simple, right? The enrolled data, it has the origin, and then it has obviously the version. It's important that you do check the version because as the standard goes, you want to verify that you are working with the latest versions. You have the challenge, and then you have the app ID that in the app ID, the URL points to a list, and demo.ubico.com is one of those facets in that application list. And the response, you can see that this is the assertion that is finished enrollment, and you can see the challenge, and you can see the origin. So this origin is used in the signing process as well, right? Because the server can reliably figure out whether this was the correct origin that actually signed it, because it can unwrap it. So this is a very critical piece. And then the registration data, this is just the web-based 64 encoding, but it has in it the public key, the key handle, counter values, and some of the other things. And then you have the cert. And so when you have the cert, you can do your cert token or the authenticator verification, whether you trust this token or not. In this case, we're using a self-signed cert. So the community needs to allow for both. If you wanted to have a rooted cert, third party, or your own cert, it's very flexible. It depends on the relying party and how they want to decide which to trust or not. So this is also another objective that the Alliance want to have is we cannot put it such a high barrier to entry to introduce this protocol that only certain companies of a certain size can produce and use these authenticator or the system. So it needs to be an open system. Yes.
So what value would a CA signed cert provide in this scenario? Since to keep the assertion you're making at registration is merely like that I control this private key. What would it matter if?
We know in the industry there are certain organizations or verticals that want that type of assurance. So it is really, we want to make it flexible. It doesn't have to be, and that's the point. It doesn't have to be some type of third-party root CA to do this, but it could. It's really up to. So we're trying to solve this first step, obviously for online authentication, but you can look at this protocol very clearly that you can apply to maybe very specific use cases in specific industries. So having the protocol flourish and used in many use cases has a lot of advantages.
Would the attestation be used in like an enterprise situation where you deploy YubiKeys out to your employees and you want to make sure that those certificates are coming from those specific keys, those specific tokens?
It could, but that's not necessarily the objective of that. It's mostly to give the reliant party the ability to trust this token or not. We don't also want to, so the attestation cert, we can have it as a batch. So you know it's made by Yubico for, there is a kind of a minimum size batch so that we don't get in a situation where we know that this particular key was for particular enterprise, right? So it needs to be big enough so that we can still have some privacy. Because if you start to create the certs and you limit down to, say, 1,000 keys each batch, then I know if you are using the 1,000 keys, if you know, because then if I just decide to give it to one enterprise, I know everybody in that enterprise has that key. So we don't want that linkability. So I think the bar we set was the authenticators need to have a minimum batch of 100,000, so that covers most cases.
But is it something that the end user could do themselves? So if I buy a bunch of tokens, I see what their serial numbers are, I see the signature, the attestation signature that tells me that they will always give me that same serial number. And then as an enterprise, I write down the list of the 30 serial numbers of the keys that I've given out to the people in the one group that I'm expecting to be able to log into the one particular system. Is that something that I could use that attestation for without the vendor having an idea what I'm doing with it?
Sure. That's up to you as the reliant party or the service to provide, but we're not going to take care in the protocol. Yep. So the next thing that we'll do real quick is the login, right? So the login, again, should be very easy. So again, going back to the notion that I'm just using a simple password or a PIN, which we're doing now for ATMs anyway, and you are getting the user to assert that he's there, and so he's got to touch the YubiKey. So the experience now you're looking at, I'm not reading off some code somewhere else on my phone, I'm not trying to wait for my SMS to get to me, and I'm not trying to do some action where cause a lot of friction, right? So I'm just plugging in my YubiKey or the authenticator, and it's flashing right now, and I'm touching it, and then it signs, and then I'm authenticated. So we really want to try to focus on usability, because in order to scale for the mass market, we need to make this usable. If it's not usable, when we introduce friction to strong authentication, then there's very little adoptability. Right, so that's the demo, which is good. I wanted to now kind of switch gears back into, this is my VMware here. So what do we do? And it's a good question because you need to always revisit this every time you create any type of open standard. Did you saw what your mission was when you start? So reusing, yes. Phishing, yes, for sure. There's nothing to phish in this case, right? Even if you had the username and the PIN, you're not going to get to the account. Key logging, public key cryptography is, it's really nothing to be key logged here. Everything, if the browser is handling, or the FIDO client is handling everything in a correct and coherent manner, then there should be no way that the keylogger can do anything about it. And we have the user experience, which is, as you've seen, I'm sure all of you would like to have that experience. I think that's given. You would like to have that. Put in a username, simple PIN, touch a authenticator to move forward. So what about this man-in-the-middle attacks? So I go back into the discussion I had about the protocol, and this is one of the considerations as well. This is a very important consideration that we really thought about very carefully when we introduced. We don't want to be solving all these issues and then create something else, create another problem. And we really thought about this pretty clear, and I'll give a pretty cute example here, is that that's where the FIDO client and the browser case really helps to solve this. Because it will know the origin. If it's natively built in the browser, it will know what the origin is. And it can tell that the user has touched it because of the protocol. So we can say, you know what, the user was actually there because he touched the token. I have that challenge. I know the server challenge. Okay, I have this origin. I know it came from here. It wasn't some other site that somehow became man in the middle and then, created this assertion. And if you choose to do it, you can implement, the channel ID if you wanted to. There are a few challenges with that, but that again is implementation that is optional. So what the protocol allows you, if for example the authenticator, and it gets a key handle that does not match the origin that it meant for, it's man in the middle. Something's fishy there, for sure. It will fail, it will not sign. If you get an incorrect origin when the relying party gets back and, get the blob back and it decrypts it and says, oh, this is actually not one of my facets in the application. It's like, okay, man in the middle, something happened here. And obviously the channel ID mismatch, which you are setting up the secure TLS tunnel, doesn't match, then you have man in the middle as well.
A question, is this the token that's doing these comparisons or the server that's doing the verification?
The first one is the token, or the authenticator. The authenticator is doing the matching. So when it comes into the authenticator, when it tries to decide whether it needs to sign, because it can derive the key handle for the respective application that it minted for in the first place. So it's going to say, hey, I did not mint this for you. This is not it. So it will not sign and it will fail. The second two cases from the server end. So we really cover both directions, right? So even if, how could you happen to be the second one? It could happen because maybe you have tricked the user during the registration process. You could never do the second one for authentication, because it would never happen. It would already know. So if you manage to trick the user to do registration with somebody else, then scenario 2 could happen. But that's fine, because ultimately when the man in the middle, the attacker, tries to send something to get something from the server, it knows, hey, this is not the origin that was making the request, so it will fail, right? So the origin that we talked about, in a couple of slides back, that becomes a critical piece, and that can only be done very accurately with the browser. And if that is incorporated into the browser's logic, then it's really, really hard to circumvent that logic, right? So coming to kind of my final slides here, but really kind of reaching out to you guys, trying to think about this within your community and how we can help, the larger community as large. You guys obviously make the browsers, and you have a very strong interest to make sure that your users are secure and to provide all these vision that it's got to be helping the community. So one of the key things we got to do is you got to look about the JavaScript API. The JavaScript API is the one that web services can call to transfer the raw messages to the authenticator. So handling the request for the registration and the signing, handling multiple authenticators, handling how to check for authenticators that have already been registered, supporting all the various versions, and error handling. So there are a number of reference codes out there today, including ones that friends and folks from Google have already done. And so to me, this is not pages and pages of code. This is a very tight protocol that you can, just a couple of the snippets, you can see how this could be implemented in a very quick way. Obviously, the second thing is that now the browser, and I think this becomes challenging because now the browser needs to talk to the authenticator itself, and you do need to make some changes there. I think that's, I would say, most of the work that you guys will need to figure out. But there are a lot of advantages for that, right? So I've described that. But basically, we are already in process. So one of the things that we've done with the Alliance and specifically the U2F technical work group is to work with the USB org to have a usage page and usage defined for FIDO. Why is that important? Because we want there to be some type of discovery mechanism. Okay, it doesn't make sense to do like whitelisting of vendor IDs and VID and PIDs. It's not a scalable solution. So if you look at what we've done, we've really tried to streamline that process so that now the FIDO client or the browser can identify authenticators that are made for FIDO use. So defining the usage is important. It helps you actually make decisions pretty quick. And then because it's overhead, you can lock down everything else. I mean, you don't have to allow a keyboard direct access to the browser, right? Because it can do bad things, right? But you only allow specific authenticators that have followed these guidelines. So we really thought about this really hard. Our CTO is really very involved in this process because obviously we make the authenticator, so we need to make it easy for anybody else trying to use the authenticators and make it scale. So this is an active discussion as well on the work group, but it's an important piece as you can see, because otherwise if you don't have this, what's going to happen? Then you are leaving it to the individual vendors to create extensions. That's not where we want to be. I mean, we need to make it simple for the general public. You can't be saying, okay, you use this, you install the vehicle extension. If you use somebody else, then you have to install another extension. Then your whole list of extensions, and it's not a day-to-day activity that the user wants to do, right? And if you go to a friend's machine, I don't want to be like installing another extension. So there's a lot of things that we really try to make it easy for any user. But again, the end goal is that the strong authentication needs to be friction. I would say no friction, but really minimal friction. With high security. So kind of to sum it up, really, we're looking at it from, okay, let's get rid of passwords. What's the first step, right? And we want to bring back some of the crypto stuff back in the browser. I really think there's a lot of work there. We are in discussions with the W3C as well. They are working on some guidelines for new web crypto APIs. So we want to drive other standards as well to kind of be in line with this. And really we're trying to bring strong authentication in the browser. I mean, that's the goal. So hopefully I've motivated you enough, and if I didn't motivate you enough, hopefully your mom will. Any questions?
So what does this look like if Mozilla, does this, and IE doesn't, or IE and Chrome don't? I mean, does this work if people start using it, but it only works in some browsers?
Yeah, so that has obviously been identified as an issue, right? So the good news is that your folks and friends at Google are pretty ahead of the game right now. They have working prototypes and even working production systems within their organization, and we're ironing out all the kinks. So if you guys do this, you're not alone. That's one. Microsoft is in alliance, so they may be the wait and see mode, but you're right. I mean, every browser should do this natively. I mean, that's the goal of the alliance, and I think we do have enough strong community support from the open standard side, as well as and the key thing is that not just from the open standard side, but from the enterprise side, there is motivation for this. So I know you guys have talked with various people before, including the folks at Google about this. I think the difference between then and now is that this has really, we are at 2-3 months away from implementation draft. So we're no longer like some initial VO, and you saw the token is V2 tokens now. So we've pretty much ironed out all the, the overall details of the specs. There are some other areas that I talked about, the app ID, facet ID discussion, and some things about the attestation certs. Those are the peripheral things. Those are important, of course, but the baseline raw messages, they are pretty set. And we have working prototypes and working production systems as well. So to kind of bring it to where we are today, it's really the message I'm wearing is now from a FIDO perspective is that in order for a new open standard to take shape and form and kind of move forward, we need more people in the ecosystem. And I think that right now we have only one company from the browser perspective involved, and I would like to see more than one.
Yeah, along the lines of the timeline, at what point do you expect to have those specs nailed down? And do you have, can you say anything about hardware vendors? Are there multiple hardware vendors that have kind of committed to providing tokens for this? How big is the ecosystem on the device side?
Device side. So device side, I just came back from the Cloud Identity Summit, and just in the interop itself, we have 4 authenticators working in production, and we have about 3 or 4 relying parties. So it's going to grow. The specs are set, and we know that the alliance is a very long list of members. We know a lot of people are doing something. Whether they choose to disclose it publicly depends on time. But it's no longer just a solution for company X and company Y. So we're beyond that discussion. It's how do we get more XYZ, ABC, and so on to the ecosystem.
So making a YubiKey that appeals to your mom and other strongly
Sure.
non-technical users seems like a really significant product and marketing challenge. Can you talk a little bit about how the authenticator manufacturers are working on that?
When you say challenge, what challenge are you kind of?
Just for someone who doesn't understand the problem of login, to understand what this is, why they want to buy one, why they want to not lose it, what the corner cases are when they use it or they leave it in their machine and they come back and some web page they've never seen before is asking them to press it.
Sure. So there's also a lot of work in the FIDO Alliance in terms of the education aspect of this. We've created a marketing work group specifically to address this because it is going to be a challenge. But if you can think about it from a different angle, what are you not wanting your end users to do? That's a better way to do it. So what we're not wanting to do is remember another complex password. So if you look at it from that angle, there's a lot of room that we can explore there. So I think it's about education, and it's about not having my mom call me in the middle of the night to say I forgot the password.
There is a precedent in the marketplace right now. So if you're familiar with any of the overseas banking systems like HSBC, they do give you these OTP tokens, which are affiliated with a very specific account. So I grew up in India. I've lived in the US most of my life. I lived in France. I have 3 separate bank accounts and 3 separate tokens that look exactly the same. So if I have to figure out which one is for which account, it's impossible, right? This sort of alleviates some of those concerns because you can now have the same token affiliated with each of those separate bank accounts and yet have the isolation of policy and identity across all 3 of those. So that's important.
So what do we do in the interim as this takes over the world? Does this mean that we carry a YubiKey and what's the name of the new authenticator? Because it can't be YubiKey.
So
right?
it's always a YubiKey.
They're all YubiKeys?
They're all YubiKeys, but the YubiKeys can do different things. Now, that's a discussion that obviously, putting on my Yubico hat right now, we will have a solution that can solve both. Because there's nothing that prevents the ecosystem from having composite devices. So you need to, as authenticator and device manufacturers, need to come up with how do you bring your existing customers forward. So that's up to each individual manufacturer to decide. And from our perspective, we acknowledge that there will be a need for us to support our existing community and bring them to the new standard. So I would say that look out for the future of our YubiKeys that will be future-proof. So you might buy a YubiKey in the next XYZ month, and you may or may not realize it, but it already has the U2F protocol already built in. So I mean that's something for us to figure out. Again, every authenticator manufacturer will figure out their go-to-market strategy. But the point is that if more authenticators support it, then more relying parties can say there's an option for the end users. And then if there are more FIDO clients that are out in the marketplace, then it just grows. I mean, this is how SSL started, right? So I think that we need to acknowledge that this problem needs to be solved now and not keep pushing it on. I mean, I think that's what we've been happening for the last, you can name number of years. And I, I went there for all the these summit, conferences, but this is just not addressed. This has been pushed every year and just said we need better IDPs. But if the signal to asserting your identity is still a username and password, it's a problem. I don't care how strong your risk-based backend is. If one of your signal is a username and password, you're giving a wrong signal. I mean, so we need to recognize that as an industry, as a community, and say that it's time for some change. And we can't do the same thing again and hope it just goes away, because every day there's a new web service that comes up, and you are going to register with them with using a username and password. Yes?
How do you imagine using this hardware in mobile devices?
That's a very good question. So today I specifically talk about the FIDO client being the browser. There's nothing preventing the FIDO client from being an application on a mobile phone. And so there's, again, in the work group, we have a couple of things in parallel. We have today a proposal for Android APIs. We also have proposals for other transport mechanisms besides USB. So there's nothing in the specifications that prevent other modes of transport. And if there's some future transport mode that we don't know about today, you should still use the same raw message protocol to transfer those assertions, right? So I think that's why I think we're really excited, is because we're not binding it to one company, one technology, or one type of ecosystem. This should grow.
So you're talking NFC or Bluetooth Low Energy or something? You put your keychain next to the phone and they talk to each other?
Possible, yes. So yeah, Android APIs calls for NFC, and there's also BLE proposals on the table as well. So I think, but even before we get there, the first step is to make sure that our USB stack and overhead is solid, because then is the framework and the foundation for building every other transport mechanism. So we want to go live implementation draft with, at minimum, the USB transport. And then maybe V2, V3, that's when, probably more people are going to come in the ecosystem and they can give their feedback. But as it is, there are a large number of these, both device manufacturers as well as relying parties, that are making those claims on what they should and shouldn't be doing. So I think this is being formed at a much high level as well as a low level discussion. It's a good question there. I would like, we putting on my Yubico hat here, we are planning to release a BLE device sometime as well. Yes.
What about the physical security of the token? If I just steal your token, then I can log into any of your accounts.
Very good question. Again, these are all very, very actually relevant questions that that come into mind when you implement this. So again, the specification itself has room for innovation. And let me explain that a little bit. Today, you are using this physical key, and there's no verifiable way that I am the owner of this token. If I am in possession of the token, I can really be you, right? So that's first step, right? But you're doing it today with your ATM card. So if you're not doing one of these, right? If you're not doing one of these, then yes, it's true that anybody picking up the token can do it if they, again, but still a second factor, right? They still need to know your original username and ID credentials for that service. Given it could be easily phished, but then this is your strong second factor. But there's nothing in the protocol today that prevents additional layer, which is you want to add biometrics, you want to add a PIN to unlock this. In fact, at the recent Cloud Identity Summit, there was a demonstration of an iris device that could, over the U2F protocol, verify the user. So there is capabilities to that. But again, you need to understand that we are dealing with your moms. So adding more work, again, adding more work is also comes with a double-edged sword. So we need to keep that in mind as we move forward. We need to take a step. We take too big of a step, and then we have failed user adoption, then the protocol will not succeed.
And
Yes.
it sounded like a TLS channel ID would be put into the signature as well, so that would tie it to a particular browser.
That is definitely a strong option. The reason why that is not mandated is there are still some technicalities around channel ID, especially regarding proxies, and you understand why. I mean, this is a problem of in an enterprise environment, there is a need to be a middleman, but they are the only middleman. So, because of, data leakage and stuff, they need to have that, proxy server or whatever. So there are some challenges around that. So we can't mandate it because, again, we can't lock it down to one specific industry, one specific company, or one specific use case. Yes.
I was just wondering, so you want to see this implemented in a browser, but what about use cases where a browser isn't authenticating a user, like for a VPN or SSH keys or GPG keys, et cetera, and so forth? This is, like, I think, a big shortcoming of all of the browser-centric authentication mechanisms, is that for things where you, in a sense, maybe even want the strongest, even stronger authentication, like for my own personal GPG keys, I can't do this conveniently, and then it breaks and it falls back apart to the original bad situation.
Sure. And that's kind of where I pose it back to you. You see this protocol, you see the specifications, you see this, given one use case, but it's a very big use case. There's so much innovation that can be done with this protocol. And I think that if I am a authenticator device manufacturer, and I say this protocol works, and you know that there are 10 other authenticators that work with the protocol, there's a lot of motivation from a relying party to figure out, or from even the ISVs, to provide solutions around the enterprise products, right? Because one of the number one things that I would say that it's tough in any new ecosystem is to seed the market. But once the market is seeded, I expect this key to do much more than just, for example, check my Gmail account. I mean, I'll be honest. I mean, I just don't want this to just do one thing. I mean, I want this to do a lot of things. And if more services, software vendors start to implement this protocol natively in their product, which I don't think it's out of the realm of possibility, really, then we have this golden ticket that we can actually see the light at the end of the tunnel. So I think we are addressing today online authentication, I agree, but there's so many other use cases that we can solve, because if the framework is built right, then we're just layering another type of methodology to enable this.
This question is kind of outside the scope of the protocol, but how do you imagine doing, like, recovery? Like, say I lose my device, what is that story like for U2F?
Yep. Recovery is a specific area that the protocol today has not addressed with the U2F side. There's some specifications in the UF side for deregistration, but specifically on the U2F side, we haven't seen it as a showstopper, so to speak. Not to say we won't address it, but in terms of the V1 specs or the first implementation draw specs, we have chose to let it up to the individual relying parties. And the reason is it's twofold. It's, first of all, if you make this first draft so bloated, it's not going to get out, right? I mean, that's, we all know we can spend years and years creating open standards, and if nobody actually implements something like this, it just, it doesn't go anywhere. The second is more from a practical perspective. Today, majority of the relying party have a recovery mechanism. You understand, this is the second factor. So most systems today already have some type of, whether it be it SMS, which is not so good, or print this code and keep it in your drawer. Some people have that. So there's going to be a lot of innovation in space, and I think there's going to be a set of companies that will come up with an intelligent way to manage your keys, so to speak, and we should not limit that form of innovation. So that's a big area for innovation, actually.
Any more questions? Nothing on the IRC. All right, thank you so much for presenting this. This is wonderful stuff.
Thank you. Thank you very much for your time. Okay, thanks.